Okay, welcome everyone to this second joint event, the second joint initiative about the AI Spotlight Seminar between the Associazione Italiana per l'Intelligenza Artificiale and the Society for the Study of Artificial Intelligence and Simulation of Behavior in the UK. Today's speaker is Elena Simperl, and I will just give the stage to Floriana Grasso to introduce the speaker and her talk.
Sure, thank you, Antonio. So again, welcome to the series of seminar, and this is a seminar in association with the AISB. It is an immense pleasure for me to introduce Professor Elena Simperl. Elena is Professor of Computer Science at King's College London. She's Deputy Head of the Department of Informatics, she was appointed recently, a year ago, roughly, Director of Research for the Open Data Institute, ODI, she leads the Institute's research strategy. She is also Fellow of the British Computer Society, former Turing Fellow, and so on. She's been leading on a number of two-digit number of European and research projects, national research projects. Her research is at the intersection of artificial intelligence in the social sciences. But I think today she will have an interesting take. So she's not talking about her research squarely, but she's talking about an initiative or an organization, in fact, ML Commons, as you will have seen on the abstract, on a talk which is very relevant. We were just discussing at this moment in time where artificial intelligence is basically booming, in very many aspects. I mean, the boom of the LLMs, the large language models, is only maybe the peak of the iceberg of the new area of AI. She will talk about responsible AI. So she will introduce a number of questions that are very relevant and very important to be asked at this moment in time. So without any further ado, I'll talk even more later. I'll pass the mic to Elena, and enjoy the seminar, as I'm sure you will.
Thank you, Floriana. Thank you, everyone, for being here. As I was introduced, so I have a background in AI, specifically in knowledge engineering. So my whole life I've been building knowledge bases, mostly manually, because historically we used to try to create computational representations of knowledge by sitting down with domain experts and trying to encode what they were telling us in computationally expressive and efficient ways. Increasingly, though, we're also using automatic methods, including the latest advances in AI. So that's a little bit of about my background. As Floriana said, today I'm going to speak about an initiative I am involved in, called Machine Learning Commons. So this presentation will feature some of my work, but is actually an overview of a range of that are led by the community. And my call for action to start with, that already, is for everyone in the audience, and perhaps your collaborators, your students, to have a look at these initiatives, to see whether there's anything that we do that is interesting to you, and participate. And why do I think this is important? We've gone through huge advances specifically in machine learning, natural language processing, computer vision, at a very, very fast pace in the last, not just in the last 18 months, but also, say, in the last 5 years, that have led to a number of tools and architectures and solutions. And we are now at a point with the AI hype that ChatGPT and related tools have created, where we, as a research community, but also beyond, are asking ourselves a question about where is this field going? Where should this field be going? How far should we push this technology? Are certain use cases ethical or not? Are certain capabilities that AI models and systems have or have not yet reached today responsible? And these sort of questions are which have a technical component, but also have broader social, economic, environmental implications, should not be taken, should not be answered and decided by one organization or one government, but by society as a whole, and by communities that come together and take decisions together. And that was the mission of ML Commons, which has been set up in 2018 already, to create that ecosystem that spans across research groups in academia, but also industry and the third sector, to accelerate innovation in AI, and ensure that we are working on things that really have a positive impact in society. And this is reflected in the guiding principles of the organization, which you will also find on the ML Commons website, which mention things like taking an inclusive approach and get everyone involved. So AI challenges are global challenges, and make it as easy as possible for individuals and organizations to get involved with different working groups and task forces. Make a difference through collaborative engineering. So we're working on very specific outputs that tend to be quite costly to realize, like benchmarks, for instance, but also that are much better and have much greater impact if built in a collaborative way. With the aim ultimately to have that community that people are excited to be part of, and drive technology advances in the right direction. So the community itself by now has more than 125 member organizations. So on the slide here, you see a number of logos that are very well known in the AI space, like NVIDIA and Meta and Google and others. But you also see in the membership that there is a global reach. So we're not talking just about US-based or European companies. We're talking about companies all over the world. And it's not just the private sector that is involved, but there are many contributors from academic institutions. And at this stage, I should mention, so the way to contribute is twofold. So an institution, say a university or a company, can join as a member or as an affiliate, and there is a fee associated with that, and a number of rights that come with that fee. But as I was saying earlier, this is all about allowing and encouraging as many people as possible to contribute. So individual contributions are at no cost, and that applies to most activities, so working groups and the likes. And on the slide, I have listed just a number of universities. Again, there's contributors in various roles and capacities to from all over the world, not just say Europe or US or China, where a lot of AI development is happening. So what is it that what is the work that the community does? Well, so a lot of the effort historically and today as well has focused on creating those or agreeing on those useful measures of quality and performance, and building a collective understanding of what those approaches to assess performance should be. The focus is on open outputs with contributions from anyone interested. And I mean, I think everyone listening to this seminar knows that benchmarks in certain areas of computing and AI are essential to drive progress and to ensure that um, the advances that we make collectively as a community, but also individually for model developers, are benchmarked, are assessed in a transparent and systematic way. And by doing this in a collaborative way, there is not only an opportunity to spread the costs and the efforts, and these are not negligible for large data sets and benchmarks, but also to make sure that the community pursues the same objectives. And when that sort of concentration of effort and interest is happening, that progress is achieved faster. On the slide, I have also listed a number of the benchmarks that are currently being pursued in the community. So at the top is the latest set of benchmarks that ML Commons has launched, I think, around 6 months ago, or a bit more than 6 months ago, focusing on AI safety. But there's a lot of excitement around a number of other benchmarks in training and inference in different settings, with a focus, for instance, on high performance computing and efficiencies, with a focus on different types of devices, specific memory constraints and requirements, and so on and so forth. That's so ML perf, so machine learning performance, is historically been the initiative in which lots of this benchmarking efforts were carried out. And this slide is just showing an evolution of the work from 2018 onward. So what it offers is, at the end of the day, a more systematic approach for the field as a whole to advance, including a standardized methodology for training and standardized ways to measure different types of parameters. And there's a few benchmarks under development. So besides AI safety that I have mentioned earlier, there's, for instance, work that is happening around developing benchmarks for the automotive sector and for healthcare as well. I've already mentioned AI safety. So this has been launched, I think, maybe 3-4 weeks ago. So it's a proof of concept towards achieving standard benchmarks for evaluating AI safety. So this is a huge topic at the moment, not just in the technology space, but also of interest. For instance, from regulators, for instance, in the context of the EU AI Act, or similar existing or emerging regulations in other parts of the world. And the question there is, what should be the approach for different types of tasks to assess that a system or a model is safe or not. In this particular proof of concept that was launched recently, the working group created a gold standard with prompts and classified basically those prompts and conversations according to an existing taxonomy of hazards, using LlamaGuard as the starting point on a modeling side. Now, I'm going to take a few minutes just to talk about what I call data-centric AI, for you to understand the context in which my work and the work of other colleagues in the community is being carried out. So data-centric AI is, I could call it a movement, but it is an approach or a set of related approaches in machine learning and related areas that acknowledge the huge role that data, as opposed to models, play in ensuring that AI systems are useful and change the world for the better. And that is particularly important in the age of foundation models, where lots of AI systems and products and services today are built using existing pre-trained models as a commodity. So in this new world, data really is the new codes defining the best possible functionality of a model. So against this background, at the Open Data Institute, which was briefly mentioned in the introduction, we have a program of research called Data-Centric AI, which I'm going to briefly go through, and then we're going to go back to ML Commons and how data-centric AI is being explored in ML Commons. But just a few words about the Open Data Institute. The Open Data Institute is a non-for-profit. We are based in the UK. We've been around since 2012. We're an independent, non-partisan organization that has been set up by Sir Tim Berners-Lee and Sir Nigel Shadbolt, with the aim to create a world where data works for everyone, and that may mean data in an AI context, but it may also mean data as in open science, open data sets that are used for science, or open government data that leads to better services for citizens. That this so-called data spectrum that the ODI has produced is one of the most well-known outputs of the work in the last 12 months. Basically illustrates that whole spectrum of data resources and data assets that the ODI is working on to realize those open ecosystems around data. With, if I may say, impressive impact from jobs created through and supporting startups and other new data products and services, to a very successful data literacy program with more than 50,000 people trained, as well as contributions and leadership in a number of data standards and development of open data infrastructure that is used by government, by scientists, and other organizations. So at the ODI, as I was saying earlier, we have set up in November last year a new program of research around this topic of data-centric AI that is structured. So it is an interdisciplinary program of research and advocacy, bringing together expertise from AI, data management, but also social sciences, ethics, economics, environmental sciences. And the program itself is structured across three different themes. One is around making existing data easier to use in an AI context, or making it AI ready. So we are carrying out original research. We are collaborating with partners to enable and support high quality AI data sets, think about or carry out studies to understand whether existing rights, individual and collective, are respected as data sets are created and collated and used in an AI context. Think about the stewardship and governance of key AI data sets that a lot of advances in AI these days is based on. Lobby and encourage organizations to invest and continue to incentivize public good data sets for innovation, and build communities and work towards establishing standardized best practices to to assess the quality of AI data from a data quality point of view, as it is done, for instance, in data management and information systems, but also now for instance, from an AI safety point of view. The second pillar of the program focuses on making AI data sets easier to access and more usable by a wider range of stakeholders. So we are working with a number of key data holders to come up with methods to study data sets that are really critical, benchmark data sets, for instance, and document them and their limitations so that we have a better understanding of the link between the quality or the properties of the data and performance of models. Through our policy and advocacy work, we're working towards mandating fair and equitable data access for critical use cases in which AI is already used, for instance, in climate, in healthcare, and misinformation. Our contributions to ML Commons fall into this third bullet point around investing in data standards, which are critical to reduce the costs of data access, especially for smaller players who are not particularly informed or up to date with the latest advances. In particular, given current data monopolies and other inequalities in the ecosystem, we are working to fundraise programs to enable safe access to data by startups and SMEs who perhaps don't sit on those data resources as some of the bigger companies. And we have a project with Microsoft where we're looking at AI co-pilots for data work, for instance, to search data, to make sense of data, with the aim to understand whether these sort of tools could make it easier for people who don't have that sort of level of data literacy or a data science degree to still be able to take a data set available in a technical format and ask questions on it and be able to make decisions on it. And finally, we have a third pillar focusing on making AI systems use data responsibly. So a lot of focus in AI systems development has been on models rather than on data. Data is seen typically as a static artifact and maybe is used to train the model, there are no further considerations about how the quality or the properties of the data, or the fact that it needs to evolve, or it has questions around the way it was collected and copyright and whatnot. Those questions don't really play a big role in AI systems development. So for this reason, we have this third pillar. So in one project, we are thinking about what sort of computational and other methods could we come up with to learn more and be able to extract information from existing sources about the provenance and lineage of data, We are designing innovation programs to encourage investment in research and innovation in AI models that rely less on massive data collection, so that to break some of those trends that we have seen in the last 5 to 10 years. We have a project at the moment at the ODI where we are running qualitative research, so surveys and interviews with various types of stakeholders to understand the types of licenses that one would need to design to respond to specific AI concerns. And would love to do more to take existing research in responsible AI to create more practical toolkits that are supported by peer learning and appropriate training for AI engineers and practitioners. So that was a short summary of the data-centric AI work I'm doing at the ODI, which motivates the my involvement in ML Commons in two initiatives. One is a working group around data-centric machine learning research, and the other one is the Croissant Working Group, which develops a web vocabulary to describe data sets in machine learning. And I'm going to tell you a little bit more about this. So how is data-centric AI lived in ML Commons? So I've mentioned the data-centric machine learning research working group. We just had a workshop of this working group at iClear last weekend. So the aim of the working group is to establish data-centric benchmarking practices rather than model-centric ones, to overcome those sort of limitations of static data sets that we see in standard benchmarking. So for that, the working group, this is not something that I have been involved in, but the working group has created data perf, so data performance, which is all about benchmarking data and data-related algorithms while fixing the model essentially and varying different properties of the training or fine-tuning data. And the way they work is by creating these benchmarks and then organizing challenges and competitions for the community to get involved. So I'm going to provide a number of examples of some of these challenges. So as an AI researcher, for instance, you could get involved and propose your own challenge. On top of data perf, you could join some of the existing ones that are opening, or for instance, you could use some of the challenges that are currently live in education to demonstrate some concepts, like for instance adversarial learning, as I will show in an example, to students and encourage them to contribute to the ecosystem as well. So it's three types of benchmarking, data-centric benchmarking activities. One is really around benchmarking training data sets. So there's a set of fixed models, and there's variations in the training data that impact on the metrics. Then the working group is also working towards benchmarking test data in terms of in creating new data sets, but also creating new metrics that capture the novelty in the test data relative to the existing one, and what that means in terms of performance. And then there's a lot of work in benchmarking a number of algorithms for data manipulation, basically. So algorithms that take a slice of the raw data and use it to train models or perform other transformations. Now, very, very briefly, these are some of the challenges that you could get involved in. So this is one that with the goal to select the best training data from a global pool to maximize performance for crop classification. There is another very interesting one related to large language models, which aims to create a benchmark for health conversational agents that better reflect the understanding and the preferences of regular patients or people. So this is a new one that people could already get involved if they're interested. It's led, I think, from the University of Oxford. The contacts are all on the slide. So there's two phases. In the first phase, the plan is to run trials with people using large language models to self-diagnose, for medical self-diagnosis. And then in the second phase, the transcripts that will be collected from the first phase will be used to create a fine-tuning data set that will then be used as a baseline for a challenge, a model-centric challenge. Prism is also a project from Oxford, if I'm not mistaken. This is a completed project, and the aim was to try to understand just how diverse human feedback can be across cultures and different types of backgrounds. So this was a project about the diversity of fine-tuning data sets of chatbots, online chatbots, and the considerations and the complexity really of creating and assessing the properties of those data sets and the impact that different participant-related or preference-related properties in the data can have on the performance of the models. This is a new challenge as well on data-centric image classification, which I think it is run from the university in Germany. So again, this is one of the ones that is very early stage. So there's a lot of opportunities to get involved. ML Commons will start a project with Common Crawl, which probably lots of you have already heard about. So it's one of the, if not the only large web data set available that has been used for many other types of research before the rise of foundational models. Now it has come to seen a lot of attention because of the way it is used, for instance, as in a curated form as the PILE or the C4 dataset in pre-trained large language models. But there's a partnership between Common Crawl and ML Commons with the aim to do better at curating a multilingual data set that can be then used for training and in AI. We all know or have heard probably about the lack of diversity in terms of languages in many text-based corpora. So to improve this and to improve the way the data is collected, we're going to be first recruiting volunteers to create this gold data set with appropriate language identification. Then there will be an evaluation step with existing models. And then again, just like in all the other examples, there will be a challenge for those in the community who like designing models to come up with new ways to do that language labeling. This is a challenge that hasn't been launched yet, is coming up in July. It's a data collection challenge. So the aim here is to improve the diversity of image data sets with public website that will be accessible to everyone. And the aim would be to have images and captions that represent people and social activities and communities from all over the world to reduce some of the biases that are inherent to pre-training models just on existing web data. I'm going to skip through this because I want to give us a chance to have a bit of a discussion as well. Maybe a few words about adversarial nibbler. So this is a text to image initiative where the aim is to collect prompts that generate images that safety filters miss. So I don't know if you can see here on a slide. So this has been going on for at least a year, I think, and the aim is, and what is doing is asking people to type in and to submit prompts. Like for instance, I have submitted last week a dog eating a tomato. So there's nothing in that prompt that screams unsafe. But actually, as the models start generating images, that red color of the tomato and the way it is placed and it is displayed already can create some very disturbing effects. So the aim is to have a rich collection of those prompt image pairs, and more than 6,000 of such pairs from 300 active users in 100 countries has been collected, and they are now entering a second stage to collect more data. All of these data sets and benchmarks are available openly. I and others, we know that open data plays a huge role, and the web play a huge role in where AI is today. In fact, a lot of research, including corporate research, done in some of the big tech companies, is clearly influenced and relies on this availability of open data sets. And that's one of the reasons why ML Commons and the community wants to also invest actively in creating data sets that are critically missing. I'm not going to go through this in detail, but just perhaps provide a few examples of some of the data sets that the members have created together. So this is a data set, a speech data set with more than 30,000 hours of transcribed English speech in different dialects. So the aim there is to acknowledge the range of dialects from foreigners, from people speaking English in different parts of the world, and to use that in speech processing. The multilingual spoken words is also similar in the sense that it is about speech as well, but it is about different languages and a number of specific words that are spoken in more than 50 languages. So now we're getting to Croissant. Croissant is a working group in ML Commons, is the one that I am co-chairing. And we have launched the first version of this open format, more or less, I think, at the beginning of March. So what does it do? It is a web vocabulary that describes machine learning data sets. And it has 3 use cases. So one is to reduce the friction that developers today encounter when using a data set across different machine learning tools and platforms. For instance, if you use PyTorch and TensorFlow. The second use case is to make it easier to publish, discover, and reuse machine learning data sets. Again, with that thought in mind that many times machine learning practitioners are focusing on models rather than the data that they are creating, and thinking about questions around the governance and the stewardship of that data. So making it easier to support some of these activities and also support responsible AI, in particular responsible practices around data. So this graphic here on the right-hand side gives an overview of the main stakeholders, data creators, data users, and we're also in the working group working closely with several data repositories that hold more than 400,000 machine learning data sets. In particular, the format is supported by Hugging Face, by Kaggle, as well as by Dataverse, and we are in conversations with a number of other repository providers. So what's the background for this? So why does one need a standardized way to describe data sets at all? And why does it have to be a web vocabulary? And I've provided the background in 3 slides, and the first component of this background is the semantic web. So the semantic web, it is a 25, 30 years old idea, introduced by Sir Tim Berners-Lee and others. And the main message was that there would be an extension of the web, of the open web, as it used to be back in the day, so that web information has machine readable meaning attached to it. As you can see here on the Scientific American cover, I know what you mean. So the idea was that when you carry out any sort of task on the web, the agent would be able to not just process that information syntactically, but also semantically. And on the left-hand side, I have added one possible technology stack that has been implemented by, that has been developed by the W3C standardization body over the last decade. So this is one component of croissant. So this idea that on the web you publish web pages, but also data sets and other types of digital assets, and you have machine readable representations of what those assets are about and what they mean. The second piece of this puzzle is one particular vocabulary to standardize how you describe those web assets, in particular, in this case, the data sets. So schema.org is an initiative by Google and other search engines. And their aim is to run a community process to standardize how we describe things on a web in a machine readable way. So what are the attributes that we are using, for instance, to describe a online or offline business? There is a name of a business, there's perhaps a sector in which this business is operating, there are perhaps opening hours, there is a CEO or other types of governance, there is a year when that company was founded. So standardizing those attributes and the relationships between them is what schema.org is doing. Now, as part of schema.org, there is one sub-vocabulary for data sets. So it entails a number of general purpose attributes to describe, for instance, a CSV file or a collection of files that is published as a data set distribution. So schema.org dataset, for those of you who know about web vocabulary, is similar to formats, for instance, like DCAT. The third piece of this background is a tool called Google Dataset Search that is using a similar technology as Google's and other search engine, indexing the web, looking for objects, web resources that are annotated, that have markup expressed in that schema.org dataset language, to create an index of datasets and provide search functionality. So for a data user to be able to find datasets independently of where they have been published online. So we have that idea of the semantic web that is implemented, among others, with the help of these standardized vocabularies like schema.org, that, among others, facilitate services like Google Dataset Search. So we have used all three in Croissant. Oh, the slides are a bit all over the place when I uploaded them, but this should say metadata attributes. So we've created this vocabulary building directly on top of schema.org dataset, capturing information about machine learning datasets to meet the requirements of those 3 use cases I mentioned earlier. So from a design point of view, there's 4 classes of attributes. One is general information, so-called metadata, including some machine learning specific attributes like features and labels, as well as a whole number of attributes that are interesting from a responsible AI point of view, like, for instance, known limitations of a dataset or documented biases. Then the second layer refers to how the source data in that dataset is organized as files and sets of files, so directories or sets of homogeneous files. Could be images, could be text, could be various other modalities. There's attributes that capture the structure of those files and file sets, including options to do some basic data manipulation using regular expressions and JSON path. And then there's a number of attributes that have to do with the loading semantics of the data. So loading semantics as in how a tool like TensorFlow or PyTorch or any other machine learning platform would read and understand those collection of resources that are structured in a very specific way. So that fourth layer includes a number of machine learning specific data interpretations with that interoperability between tools in mind, as well as a number of custom types like bounding boxes and ways to organize the data that are specific to how those data sets are used, for instance, train and test splits. So it's an open vocabulary on the ML Commons website. You'll find the specification, and all implementation and examples are available on GitHub. Now, very briefly to walk you through some of those use cases. So if someone needs a machine learning data set, they could search for it just like they search for any type of data, for instance, using Google Dataset Search that is supporting the croissant vocabulary. It could go to one of the main repositories. So if you, for instance, look at, if you go on Hugging Face, you can download that croissant metadata. A user can also load a machine learning data set in different platforms without making any changes. If you're working to create or publish a data set, we have a Python library to validate croissant metadata, but also to take existing data sets and create some of that metadata automatically. And we have a visual editor that allows one to create and modify the data. So you can upload the data set, you can describe the attributes that you have, and you can get some automatic recommendations on the attribute values and improve the values manually. So the vocabulary itself is modular and extensible by design. So one of the extensions we've been working from the very beginning relates to specific use cases around responsible AI. So fair machine learning, safety, attributes that capture how labels have been created by annotators, for instance, in supervised context, but also now for fine-tuning and preference elicitation. We have attributes for regulatory compliance, and in particular for transparency. We have just launched sub-working group that is looking at geospatial data sets and the attributes that are required there. That is led by NASA. And we are looking to launch another one on healthcare that, among other things, is also going to look at questions around attributes required in the method at the metadata level when the data itself is not available for privacy or other sensitivity reasons. The first version of the responsible AI extension is available, but this is very much ongoing work. And with that, I leave you with two additional announcements. So I have mentioned the healthcare extension of the croissant vocabulary. This is going to be one of the topics of a workshop we are organizing in Geneva at the UN AI for Good conference. So this is going to be on the 31st of May. So the aim there, we're collaborating with the UN AI for Good program to come up with a set of data sets that are properly documented and assessed, that can be used for the scenarios that the UN is interested in. And the second initiative I would like to point to before I wrap up is a new journal that the Data Centric Machine Learning Research Working Group has launched, which is already available for submission, and they're also seeking reviewers if you're interested. And with that, thank you very much, and I'd be happy to take some questions.
Thank you. Thank you. Thank you, Elena.
So I'm opening the floor to questions, of course, and while we wait for our audience from the chat, I may maybe have a start. So I was interested very much in your collection of the collection of projects that you've shown, the initiatives, etc. And if I may kind of link it to one of your final slides on the semantic web, because of course the semantic web as a vision has been there all the way, and there's always been the thing that you've described pretty much so far. So the idea of really getting collaboration happen, and I guess my question is, are we ready now? So have we done enough during the past 20 years, 25 years, to kind of tackle this massive uptake of AI as a service, really? Because this is what is happening now. So whether it is research, and many of the projects you've described are really aimed at researchers that know what they're doing, hopefully. But the kind of the change of paradigm now, the paradigm shift now is to have the general public using AI without basically necessarily knowing exactly what they're doing, with all due respect, of course. So are we ready? Have we done enough to be ready, or is the horse out of the stable already?
So that's an excellent question. So I think two components, two parts of my answer. So first and foremost, if we understand the semantic web as a web where web pages, data sets, images have that sort of semantic markup linked to it that allows one, for instance, to implement a different type of search or recommendation, that's been around for some time. So the Google Knowledge Graph has been launched in 2012. Schema.org is also around for many years, and there's many other examples. So every big internet company, but also companies that work with content like Netflix and Amazon and others, they have their own knowledge graphs, and they are using that to provide better search recommendation and so on services. So that has been around. That whole idea of the semantic web was going beyond that, right? So, and it was it was going towards some functionality that require way more than what we have seen today, even with the latest large language models and foundational models. It requires reasoning, it requires multi-hop reasoning, it requires perhaps different ways for those AI agents to set goals and break those goals into sub-goals. So I think the original example was something around travel planning or calendar management or something. Yes, you can perhaps solve some of those tasks with a crude method and just throwing lots of data at the model and hoping there will be enough in it for it to learn. But even if you think about calendar management, I don't think that's solved yet. If you think about travel planning, that's also not solved yet. And but I think what this latest wave of AI has done is it opened a conversation around how what do we want, where do we want this innovation to go, and how comfortable are we with the fact that it may or it may not become more powerful. Though, I mean, personally, I think that even before we had ChatGPT, there were quite a few technologies around that could create harms. Um, but and then the last point, and that goes back to, so I think where we have not made any progress at all is, in fact, what we've done is we've moved away from that open infrastructure that the semantic web idea had. So it was all based, that technology stack that I have shown, it was based on the idea that there wouldn't be any data silos, that you would be publishing. Yes, some data would always be closed, like according to that ODI data spectrum, but the data that would be published openly or online would be available through the same type of architecture and access means as any other. And it would be available to everyone, and we don't have that. So the public AI infrastructure is not available. We are putting all our prompts and doing all our preferences into closed systems.
It
And
is
while
not
it's true
because
that research is based on open data sets, the systems that we are using are not, they're closed systems. And that's very different from that semantic web idea.
Is it because we've been lazy all throughout this time, or we've been concentrating on our,
I don't know.
backyard project instead of thinking?
I suppose this development that we are experiencing right now comes against the background of consolidation and platform silos that has been happening for quite some time. So, and the same, and it has to be seen in that context.
It is. I mean, and it is. It is true also that there is an element of not compliance in a way. So we've done some research with some of my PhD students on exactly how interoperability works and how it is in practice working, and all the recommendations from semantic web, ontology engineer, etc. really are not taken all the way through from developers, so that there's not a proliferation of I don't know, metadata. There's not a proliferation of competency questions, just to say one thing. So it is even from developers. So it is it is biased from the start. So and now I think we are catching up because we have to, because of the new developments.
Yeah.
Any
I have a question.
Yeah, sure.
Can I?
Yeah, go ahead.
Okay. So I'm curious about your opinion. What you think about the fact that, in a sense, the semantic web, the main message of the semantic web is that one of the main messages, that by adding labels, metadata to our data, and hopefully these metadata, the label that we use are described, the semantics is described by ontologies and so on and so forth. But actually, I mean, there are a lot of metadata which do not have ontology attached, or such that the ontology doesn't really specify the real semantics.
Yeah,
So large language models instead provide a natural semantics for label for metadata. I would like to learn to understand what you think if we what What about considering the semantics of metadata labels provided by large language model and use them to, to retrieve, to organize, to do the task for which metadata
Yeah.
label are given?
Um, I mean that's it's a very interesting question. I mean, I agree with you that everything that or lots of the data that is available on the web, even if it is described according to standardized vocabularies, those vocabularies don't have a formal semantic. Um, with large language models, I mean, one could, I suppose, help create richer metadata and richer descriptions of those resources. So, for instance, one project we're working on at the moment is in revisiting linked data and looking at those layers at the top. So it's a 5 point scheme where the higher you get, the more reusable basically your data becomes. But we also know that the layers at the top are quite um, resource intensive to achieve. Just to give an example, so convincing people of the advantages of not publishing data as PDFs is already quite a big step. But then thinking about RDFs, thinking about RDFS and other ontologies takes a lot of time. So one project we have at the moment is to try to see whether we are using some of that bottom up semantic that or representation that the LLMs can provide to help people reach those sort of levels in data publishing. So in a way, uh, trying to cut some of those costs or efforts that are required to create those richer representations.
Okay, thank you.
Thank you.
I have a question that reached us through email by Antoni
Okay.
Skakas from the University of Cyprus, which I
Yes.
say my
Yes.
hello. So the question is, you mentioned that the work for data-centric AI is interdisciplinary. How do you achieve an effective synthesis of expertise from different disciplines? Do you have a model for organizing and managing this synthesis? Perhaps protocols for the effective cooperation between different disciplines?
Yes. So there isn't a model as such because there are so many working groups with so many different topics that each of these working groups organizes their work in a different way. So, for instance, in automotive, you'd have people who come from that area and have the domain expertise. In AI safety, there are people who work in responsible AI. You have AI ethicists. You have very different backgrounds who are contributing, for instance, to benchmarks and approaches on online toxicity. In Croissant, we have people who work in healthcare data management. We have people who work in geospatial data. We have people who create cultural heritage data sets. So I suppose what I'm saying is we don't have a model as such, but we have lots of lived experience, and it's quite interdisciplinary um, in terms of the sectors as well, where those people come from.
Sure, thank you. I don't know, Antonio, any other questions from the audience? If not, I may probably have wanted to have
Oh,
another
okay. Yes, no.
mention on ethics again and
Mm-hmm,
on the bias of data, because of course
mm-hmm.
all the initiatives have spectacularly backfired. Google's, for instance, on trying to inject any unbiased mechanism in
Yeah,
data by
yeah.
heuristics. So again, what is your vision around this? How can we get out of this model?
Well, I mean, it's quite a complex problem, right? So there's, I think, from a talking from a data centric point of view, I think there's more that could be done to understand the biases in existing data sets, and that means that can start, for instance, with protocols that we require people to or researchers to submit when they submit papers. So there's a lot of focus and lots of advances on, say, holistic evaluations of models, but there's less standardized practices on data. And then equally, I think the sort of data-centric benchmarking that the data-centric machine learning research group is doing, where the models are fixed, and we are looking at variances in the training data, we are looking at variances in the testing data and their impact and statistical significant links between those properties and performance. I think if we would see more of that, we wouldn't reduce biases, because to some degree that is also quite hard, because it depends on methods of data collection and the data itself. But we would be way more aware of how to read that performance. Really, I think that would be a good a good aim to start, and then that whole conversation around what safety means and when is something safe and when it's not safe. I suppose that's a social choice as well. Not just, it's not, we shouldn't be saying that. It depends very much on use cases and many other factors.
It does, in a way, but also maybe we bound to regulations, and they are
Yeah, exactly.
more present, and we need to kind of relate to those in a more effective way, which also may mean that we will be forced not to research on a particular direction, which is the case that we want not to accept freely, but it is part of the topic anyway. Okay, so thank you very much. I think we can. Antonio, you want to maybe say a few more words to conclude the session?
Yeah, just to conclude, well, first of all, Elena, thank you very much for the talk. Very interesting. We learned a lot about this new data set and benchmarks. And I just want to give an announcement about the next Spotlight seminars on AI organized by the two organizations, Associazione Italiana per l'Intelligenza Artificiale and AI SB, which will be on June 20, and we will have Guy van der Broek from the UCLA that will talk about his research. So thank you again, and see you for the next talk.
Thank you.
Thank you, Elena. Thank you so much.
Bye.